Now we're going to look at estimating limit of a function, and we're going to do it in two ways, and that is numerically and graphically. That's what we're looking at today. This is pretty tough to explain, but once you get the hang of it, it's not that big of a deal. Not too difficult to handle. But the initial explanation can be a difficult thing for me to do. So you just have to bear with me. But again, not too bad. All right, so we're going to look at number 3 on page 743. And the first thing we're going to do is learn how to read that. Okay, so on page 743, number 3, here's how you read it. Obviously, LIM stands for limit, so it's the limit as x approaches -2 of x squared plus 2x minus 15. That's how you say it. So the limit as x approaches -2 of x squared plus 2x minus 15. So Peyton, read number 1 for me.
Limit of x approaches 5, 4x minus 10.
All right, he was close. There's 2 words in there I didn't like. He changed one of them and didn't say nothing. All right, Tanner, so tell me what it should be. What's the perfect reading at number 1?
So limit as x approaches 5, 4x minus.
Seth?
Limit as x approaches 5 to the 4x minus 10.
Anybody else? Caleb?
Limit as x approaches 5 of 4x.
There we go. Nailed it. Okay, so Megan, read number 5 for me. Number 5, read number 5 for me. You had all the right words. They're just in the wrong order. Katie, give it a shot. Number 5, read it for me.
Limit as x approaches 3 of 2x cubed minus 10x plus 4.
Very good. KG, read 7.
Limit as x approaches 0 of 5 to the cosine squared x minus cosine x.
Okay. Everybody got it? Kenzie, you got it?
Yeah.
All right, read 9.
Can we put
Oh,
that
I
all
knew you were
together?
going to do that to me. The limit of x approaches 6 of x plus sine x.
Very close. One word on. You said the limit of x. It's the limit as x.
Oh man,
So the limit as x approaches 6 of x plus sine of x.
that's what I meant. That's what I thought.
Is it the limit as x or is it as x approaches 6? Like, is it the limit d x?
It's the limit as x approaches 6.
Yeah.
All right, so yes, Becky.
Are we going to put that whole thing in our calculator?
No.
Parts of it.
We're going to put the function in there. This part, the x squared plus 2x minus 15, that goes in the bracket. All right, so there are 2 takeaways we're going to have from today that I need you to take away and have hold of and know what we're talking about. The first one is the solution to a limit is a y value. So if I ask you to give me something for a limit, you are going to give me a y value. The solution to a limit is a y value. That's takeaway number 1. Okay? So on number 3, the limit as x approaches -2 of x squared plus 2x minus 15, the solution to that should be a y value. So that's what we're looking. That's what we're interested in. We are looking for a particular y value. Okay? And that y value is when I approach the x value of -2, I'm interested in what y value will this function give me. That's what we want. Okay? So get your calculators out. And the first thing we need to do to your calculator is make sure we're in the correct mode. Your calculator needs to be in radian mode. So how do I put it in radian mode?
Go to settings,
Settings,
document settings,
document settings.
and then you're going to go down one, click the middle button, and you're going to go up one, and you're
Once you get radian selected, make sure you go to the bottom, please, and click Make Default, and then click OK. You always want to make it default and then click OK. Everybody have their calculator ready and move.
Mike,
Can you go
should
to settings?
exponential
Settings.
format be on normal?
Settings, and then go to settings.
Yeah.
And then general or outside.
Where does it say float?
Go to general.
Dude, I can't even like
It has different floats. Oh, that's fixed?
So you're already in ready, go down and click make default. Keep going down.
Wait, I don't know what it runs again. Hey, what's float and fixed?
Has to do with where the decimal's at and the numbers behind the decimal. Everybody good? All right, so we're working on number 3. So the first thing I want to do is graph that function, which is x squared plus 2x minus 15. So I'm going to do a new document. I'm not going to save it if it asks me. I'm going to do a graph. So it was x squared plus 2x minus 15. What do you know about x squared plus 2x minus 15? It is a parabola, and right now I can't see it all. What else do you know about the parabola that might help you change the window to where you can see it? The important part of it.
It crosses down. And it crosses the y-axis at -15.
Crosses the y-axis at -15. So let's go to menu, let's go to window zoom, and let's change our window setting. Now what is it I want to change on my window setting with what Garrett said? The y minimum. So let's change the y minimum. And let's make it -15 and see how close that gets us to the bottom of it. So we're a little bit closer, but we need to go a little bit more. So let's change it again.
20.
Make it 20?
Yeah.
All right. So -20.
Yeah.
Press enter. All right. So now we can see everything. Okay. So now we have enough information to graphically answer this problem. Again, somebody read number 3 for me again. Chance, read it.
Limit as x approaches -2 of x squared plus 2x minus 15.
So what is it I should be looking for? And why?
The y value when x is -2.
The y value, I'm interested in the y value as I'm getting closer and closer to -2. Okay? Sometimes that y value will be there, sometimes it won't. In this case, it's there. So, the x value of -2 is right here. So what y value corresponds to -2 from the graph? Just an estimate.
about -13.7.
We'll go with -13. So our graphical estimation is -13. Okay? And up here, as you see, it says we also want to do it numerically. Numerically is going to give us a better estimate than graphically. Graphically, we just have to estimate. Okay? Now we want to come in and do it numerically. And here's how we're going to do it numerically. We're going to set up a table of values by plugging in some x values that are very, very close to -2. Okay, so I'm all, -2 is where we're going, so we're going to put that in the middle. And I'm going to plug in, that would be -1.999, -1.99, and -1.9 on the right. Any ideas on what I want to plug in on the left?
2.1.
Good. So let's plug in -2.001, -2.01, and -2.1. So we're interested in the y values as we get closer and closer to -2. So now what we want to do is we want to plug these x values in and get the y values out. Okay? Here's what we're going to do to make that happen. We're going to set up a new page. So we're going to do Control Doc, and we're going to add a calculator. So Control Doc, add a calculator. And then I need to plug in all these values. So I'm going to press this VAR button. What do you think VAR stands for?
Bar.
Variables. Okay, I'm going to click that, And that function right there is the function that I just graphed. So I'm going to press enter, and then I'm going to start putting in these numbers up the top. So I'm going to put negative 2.1 in there and press enter. So it gives me the y value that goes along with negative 2.1. I press it again, I press enter, and now I'm going to put negative 2.01 in there. Press enter. Again, and I continue to do this till I put everything in. I'll put it in backwards. Oh no, I didn't. Alright, so now we have those values in there. Do we want to adjust our estimate of the limit?
Yes.
Yes. What do we want to adjust it to?
15.
Negative 15 is what we want our limit to be. So this right here is gone, and negative 15 is going to be our next estimate. Yes.
So instead of doing that, can you just trace the graph and find negative 2x and see what it matches up with?
No. Because sometimes that y value won't be there. Or won't be helpful. This is the way we want to do it. Okay, and we won't always have to do this. There's another method. There's an algebraic way to do it, and that's the way we want to do it most of the time. But this is the way we want to do it to begin with, so you guys understand what it is you're actually finding. Okay, so negative 2 is where we're going. So we're going negative 2 here, negative 2 there. Am I getting close to a common y value? And what is that y value? It looks like both sides are going to negative 15, so that means my limit is negative 15. So to write my answer is going to be equals negative 15. That's the answer I'm looking for. Now I want your table there to support that answer. Yes?
I think you just plug in negative 2.
Alright, great question. So, Adam says, why don't I just put a variable, press enter, press negative 2, and it gives me negative 15. Okay, it happens to work on this problem. It will not always work, such as the next one we do. Okay, so we always want to do our table just like we did here. We do not need to plug in that number in the middle. Sometimes it matches up, sometimes it doesn't. Okay, but this is the way we want to do it. So what we want is, we want to look at the graph, we want to estimate it. You don't have to write down that estimation, but you want to keep it upstairs. And then when you do your table should either verify your estimate or tweak it just a little bit. Once you have the table, then we're going to write down what our estimate is. Okay? Now, somebody tell me what it is we found here.
Where x is going, the limit for x, where it's going to go to negative 2.
Okay? So,
Negative 2.
there you go. So, as we are approaching negative 2 on this function, we are getting closer and closer to the y value of negative 15. That's what we're looking at on this limit. Okay? Let's try another one. Alright, bless you. Let's go to 11. We're going to try 11 next. And 11 has a little plus sign up there on that 0. We're going to ignore that right now. We'll get to that a little bit later. I'm not going to worry about that today. So it's got a plus sign up there. We're not going to worry about it. Alright, so what do I want to do first?
Read it out.
Alright, read it. So read that to me. Me, Peyton.
limit as x approaches 0 of sine x minus x over x.
Very good. Okay, and what is it we're looking for? What is going to be the solution? A y value is going to be the solution of this. Okay? Alright, so now what do I want to do?
Graph that function.
Graph that function. Now, I want you, whenever you start over, I want you to go to the home screen. I want you to do a new document. I don't want to save it. And then we're going to go back to a graph. So this is sine x minus x over x. So control divide. We're going to do sine of x minus x over x. Press enter. So this is what our function looks like. So now what do we want to do?
Create a new tab.
Before that,
Make an estimate.
we want to make an estimate. So what is our estimate going to be? 0 is going to be our estimate. Any questions on how we got 0? Because remember, our limit, we're wanting to approach 0. As I get closer and closer to that y value or x value of 0, what's the y value that goes with it? 0 is. So our estimation is 0. So now we want to verify it. So what are we going to do to verify it? Control dot add a calculator. So let's make our table at the top. We're headed to 0. 0 is where we're going. So what number do I want to put on the right of 0?
0.999.
That's what a lot of people think. 0 is different than any other number, though. What needs to be on the right of 0?
0.1.
The ones do. So I need 0.001, 0.01, and 0.1. And this is where 0 is different than any other number. What's also on the left?
Negative.
The ones are, but this time they're negative. If you're dealing with any other number besides 0, what should be on either side? There should be 9s on one side, and there should be 1s on the other side. 0 is the only one that has the same thing on both sides. Okay? Everything else needs to have 9s on one side and 1s on the other. So now I'm ready to plug those in. So I'm going to press variable, enter. I'm going to do negative 0.1, variable, enter, negative 0.01, and so on. So negative 0.000 or 0.1. Next one is negative 0.000, negative 0.000, negative 0.000, negative 0.000, and negative 0.001. So does this confirm our estimate, or do we need to adjust it? It confirms it. Okay, so at this point, we have confirmed our estimate, and we can say that this right here equals 0. Now, somebody raise your hand and tell me what that 0 represents. Is that
The y value, the y value we're limiting, y value x approaching 0.
okay? So that is the y value that this function is headed towards as we head towards the x value of 0. Very good. All right. Let's look at number 17. 17 is the next one we'll do. Garrett, Carr, read 17 to me.
The limit as x approaches negative 2 of x squared plus 5x plus 6 over x plus 2.
Very good. Okay. And what should our solution be? Austin, what are we looking for? A y value. That's what I want to hear. Very good. Okay, because here's the reason why I'm doing that is people, when they're doing limits, they forget what it is they're looking for. Okay, and if you keep in mind that I'm looking for a y value, that reduces some of the confusion. So that's why I keep asking, what is it I'm going to end up with? All right, so what do I do first?
Open graph.
Home, new documents, don't, and we want to do graph. So control divide. It was x squared plus 5x plus 6. What was on the bottom?
Absolute value.
X plus or x minus?
X plus 2.
X plus 2. All right, where do we get absolute value from?
Press the little button by the books.
Yeah, the button by the book right here, and then absolute value is over here in the middle left. So I click on that, and then I just put x plus 2 in there. There's my graph.
Where's the button?
Oh.
To the right, mid right,
Right.
right by the 9.
Mid left. All right, what are you looking for?
There's the book.
Yeah.
The one next to the book.
Yes. All right, so what x value are we approaching on this one?
-2.
-2. So what is your estimate on this one?
Positive or -1.
Positive 1, maybe.
One and negative one?
It cannot be two numbers.
Okay.
One.
Is it going to be a,
No solution.
what is the thing called?
Call.
Okay. Face is the closest, no solution, but we want to call it D and E. What does D and E stand for? Does not exist. Okay. And why do we say our solution does not, our limit does not exist here?
We're not reaching anything.
We're not going to the same y value from the left and from the right. In order for a limit to exist, you must be approaching the same y value as you go from the left and from the right. Okay? So from the left, where am I going? On the left side, where am I going? -1. On the right side, where am I going? I'm going to 1. So since I'm going to two different places, that means my limit does not exist. Yes.
Is it possible to have a disconnected line that does exist? Look at the line.
No. Okay, and I meant to on that last one, with what Adam brought up. Adam brought up, well, why don't I just plug the number in? On that last one,
I plugged it in.
yeah, what did it say?
Undefined.
It said undefined, because what's the problem with plugging 0 in to number 11?
You get a 0.
I get 0 in the denominator. So that's why I can't always just plug in that number, because in this case it was undefined. Okay, but I still was able to find the limit. Yes.
So if there are no fractions, can you use that? Or is it still bad?
If there are no fractions, you will be able to plug in, and that's going to be your limit. But I still want you to use the table stuff right now. Okay, I'm not asking you to do too many. Like tonight, we're only doing 6 problems. All right, so I still want to set up the table just to verify my graphical estimation. So, well, we're not going to 0, we're going to -2. So what numbers do I want to plug in on the right side of -2?
2.001.
Is 2.001 on the right side?
I mean, 1.9.
Yeah, the -1.999 is over here. Alright, then over here I've got the 0, or the 1s. And notice I've got 1s on one side and 9s on the other. Why do I know that?
There's no 0.
It's not 0. I'm not approaching 0. If I'm approaching 0, that's when I've got 1s on both sides. Okay, then I'm ready to plug these in. What do I do to plug them in?
Control doc.
Control doc. I want to add a calculator, then I start chugging away. So variable, enter -2.1. Variable, enter -2.01. And so on. So we get -0.9, -0.99, -0.999, 1.001, 1.01, 1.1. So does this verify what we determined graphically? On the left side, where am I going?
-1.
-1.
I'm going to -1. On the right side, where am I going?
One.
I'm going to 1. So since these two don't match, that means my limit does not exist.
So you're not finding the mean of them. They have to equal the same number.
They have to equal the same number or be going to something that's in the middle of it. Okay? But this one is obviously, the left side is obviously going to -1, the right side is obviously going to 1. So I'm going to two different places. Okay? Alright, one more. And that is number 27, but I want to change it just a little bit. I want to change it from x minus 5 to x plus 5. Alright. Pace, read it for me.
Limit as x approaches 0 of
F of x is fine. You can
F
just
of
stop.
x.
Yeah, you can just stop with f of x. Okay, now what do we call this type of function?
Either or function.
No, starts with a P. We've done them earlier this year. Because earlier this year we would have had something. We'd have had something like this, and I'd ask you to find f of maybe 3. If I asked you to find f of 3, what would you do?
A plug and check formula. That's what
You plug 3 in for what? Which one of those? The top one? Plug it in the top one or the bottom one?
The top one.
bottom.
The bottom one. Why do I want to plug 3 into the bottom one? Because 3 is greater than 0. So I would plug 3 in to get my solution. Okay? So we've done these before. What are they called though?
Is it like parenthetical or something?
No.
Are they close?
Pythagorean.
Piecewise functions. So that is a piecewise function is what it's called. Alright, so what's the next thing I want to do? I want to graph it. So I'm going to go home. New document. No. Graph. Now, there is a button for that piecewise function. Where do you think it's at? The button right next to the book, just as before, and it's this one right here in the top middle. Okay, so that's the button we want to get the piecewise function. So I click on it, there it is, now all I've got to do is fill it out. So I have x plus 5, then I arrow over to get to the next space, and it is asking for x less than 0. So I do x, and here's where you get all your less than and greater than stuff. Control equals. Pulls up all your arrows. So we want less than on this first one. Alright, then the other one was.
Oh,
You did that to me earlier today too. So x plus 5 over x less than 0. X squared plus 5 x control equal less than or equal to 0. Press enter. It didn't give me all of it though. Oh, yeah, you're right.
X plus 1.
I asked you to change it. There we go. So this is what our graph looks like. So what x value are we approaching? What did it say? We're approaching 0. So what's your graphical estimated limit? Looks like 5. So we're going to say it's 5. So now let's verify it. So there's 5. Numbers to plug in on the right of 5.
4.09.
What?
4.09.
5.001, 5.01, 5.1. On the left side?
4.999.
Good.
4.99. 4.9.
Okay, so let's plug them in. Control doc, new calculator, variable, enter 4.9, and so on. Alright, so I have 29.01, 29.900. Is that a 9 or a 0 right here?
That's a 0.
0. So 29 point. I did something wrong. Something's wrong.
No, that's a 9. That is a 9. No, it's not.
Why am I getting those values? Oh, I'm plugging in. Why'd you guys let me screw this way up? We're not going to 5. Where are we going?
0.
We're going to 0. But it should stop me.
I was super far off.
That's why it's important to get an idea of what it is graphically first. Because graphically we said it was what? 5, and I was getting numbers that weren't close to 5, so that told me I was doing it wrong. So,
Good job.
0.001, 0.01, 0.1, negative 0.001, negative 0.01, negative 0.1. There we go. All right, that looks better. Struggle. There we go. So does that verify?
Yeah.
Yes. Because from the left, what number does it look like I'm going to?
5.
5. From the right, what number does it look like I'm going to? 5. So that verified. So that means my solution to this problem right here is 5. And Megan, what does 5 represent? A y value. Very good. My limit equals a y value. Nice. So our first takeaway is the solution to a limit problem is a y value, and I don't think we talked about the second one, but hopefully you figured it out. Okay. Does that y value have to be there? What's an example of there being a limit but the y value not being? Now, if it doesn't exist, then we're in a different place. What's an example of there being a limit? Which one of those was there a limit, but there wasn't a y value there? Which one of those problems did we do? There was a limit, but there was no y value.
The worst one.
Which one?
The absolute value.
No, not that one.
The first one we did.
Not the first one.
The second.
The second one. Because remember, on 11, what was my limit here? It was 0. But what happened when I plugged 0 in? It's undefined. So is there a y value at 0? No. But was there a limit? Yes. So there can be a limit where there is not a y value. That's the second thing we want to take away. And that's pretty tough to put into words. Okay? You can have a limit without a y value actually being on the graph. That's what I want you to write down. Okay? You can have a limit without an actual y value being on the graph at that x value.
Not because 0 has no value.
No, in this case, if I plugged in 0, that made my denominator 0, which makes me undefined. Okay? But my graph was still going to the same place. And that's all a limit cares about, is where is your graph going as you get closer and closer to an x value. It doesn't matter whether or not that y value is actually there, just where it's going.
So it won't have a y value.
That's another great point. If it's an asymptote, what is your graph doing around an asymptote? It's got to go up or it's got to go down. So yes, there is not a y value there. An asymptote is a totally different type of deal we got to deal with. Anytime you have an asymptote, technically there cannot be a limit. Because if I'm going up, where am I going? To infinity. Is infinity an actual y value? No. If I'm going down, where am I going? negative infinity. Is negative infinity a y value? No. A limit can only be a limit if it's going to an actual y value. So technically, if you're headed towards something that's an asymptote, there's going to be no limit. But what we'll talk about is where it's going. Is it going up? Is it going down? And so on. So 2 takeaways. Limit is a y value, and I can have a limit without the y value actually being there. Those are the 2 things you can take away with it. All right. Working on those 6 problems. Ignore the directions if they're different than what we've been doing. I want you to graph it, estimate it, make a table, and then verify your estimate or modify it a little bit. That's what I'll work